Hello and welcome to this video. In this video we're going to teach you how to perform constructions. So constructions tend to be quite a practical use of maths, and we need to know how to construct a few different things. So the first thing we need to know is how do we construct what we call a perpendicular bisector. So a perpendicular bisector just means we're going to take a straight line and we're going to use a compass over here. We're going to use a compass to be able to basically divide the line exactly in half. Now these perpendicular bisectors are used for straight lines. We're also going to look at how do we form an angular bisector, which we're also going to do using a compass like this, and then we're going to look at how would we construct triangles. So these are the three things that are important to know how to do in constructions. Now for this video there will be a little bit of your imagination at play, because it's kind of hard to show you guys how to use a compass on a tablet, but I'm going to do my best. So let's start with how would we construct a perpendicular bisector. Okay, so let's say I draw this line here, okay, and I want to know how would I draw a line that goes exactly through the center of the circle without doing any measurements of the length of it, and just using this protractor over here. Sorry, compass over here. We'll use a protractor later. So what we're going to do is, if you imagine this protractor, we can extend the protractor and make it open even more. And so what we're going to do is we need to open. So step one, if I grab this, move it there. Step one is we need to open the compass. Sorry, I keep saying protractor. Open the compass so that it fits. If we put the point on here, the compass should be able to draw a line past the halfway point. So we need to open the compass wider than half of the length of the line. Okay, so wider than half of the length of the line. Okay, it doesn't matter specifically how much wider than the half the length, just as long as it's roughly larger than half the length, you should be all fine. So what you're going to do is you're going to put the point of your compass on one end of the protractor, and then you're just going to draw an arc, and your arc is going to go something like this roughly. Okay, let me try and get that a bit better. So your arc is going to do something like this. Okay, then you lift your compass off, you switch it to the other side. You're going to put your point on this point here. Keep the length the same. Okay, so second, keep length the same, and you want to draw two arcs from here past the line, and you should see that these arcs will cross at these 2 points. Okay, then what we can do from there is, if we simply get a ruler and draw a line that passes through both of these points, this line here, this line that we've just drawn last, is the perpendicular bisector. Okay, so this line will be exactly halfway between this point and this point, and this will be perpendicular, and it will be exactly 90 degrees just using a compass. Okay, hopefully that will make sense. Hopefully you can follow this with your imagination. Let's now try and use the same kind of tools, but let's have a go at constructing an angular bisector. So if we can split a line exactly in half, we should be able to split an angle exactly in half. So we're going to look at angular bisectors. Okay, so if I take any angle, right, I can draw an angle like this, for example. Okay, and this angle, I don't know the length of this or the size of this angle. I just know that I want to cut it in half. So how do I do that? So what I'm going to do is I'm again going to open up your protractor, so you open the compass, open the compass to any length as long as it fits along this line. Okay, so it doesn't really matter how open it is, just try and be reasonable with it to try and get it to be able to form some sort of curve along these two lines. So to draw a curve along the two lines of your angle. Okay, so the two lines that enclose your angle. So what we're going to do is we're going to take the compass, open to this width, keep the width the same. We're going to put the point of the compass on this point here where the angle comes together, and we're going to use it to either in one sweep or two, we're going to form an arc across this and then keep going and form an arc across that line there. Okay, using the same length. Now you can take your point off of this point here, and keeping the length the same, so you want to keep the length the same for this whole process, put your point back onto this point here where your curve has crossed this axis here. And what you're going to do, keeping the length the same, is try and draw an arc that is going to look something like this. Okay, so you want to draw an arc that goes around like this. Then you can take your point off of here and put it onto here instead, draw a similar arc, and you're going to find that these arcs should cross over, probably more like that. And then this point here, if you take a ruler and draw a line straight between this point and this line is your angular bisector. Okay, because this line is going to split whichever angle we had for the whole of this into two equal angles that will be exactly the same. Okay, so this is how we'd construct an angular bisector. You first put your point on the very edge of your angle, make two arcs, then put your point on each of those arcs, make two more arcs, and then draw a line through with a ruler. Now, lastly, this is where we're going to come into constructing triangles. So constructing triangles is a useful skill to have, but we can do it a few ways. So the first way we could do it is if we know the lengths of the triangle. So if we know the lengths or the sides of the triangle, we use a compass. And if we know the angles, we want to use a protractor. Okay, we use a protractor. Okay, so let's say, for example, that we know that the base of this triangle has a length of, I don't know, let's say 6 centimeters. Okay, and we know that the other two lengths have a length of 4 centimeters and let's say 8 centimeters. Okay, so what we're going to do is you want to take your ruler first of all. So you take your ruler, I'm just going to draw a rough diagram over here. This is your ruler with a 0 point here, and you want to take your compass, and where this is your pin of the compass, you want to open the compass up so that the pencil is 4 centimeters away from here. So your compass will go up and then it will come down, and this will be your pencil on this side, and these will be 4 centimeters apart. Okay, then what you want to do, pick either of these sides, place the pin, so this part of your compass, on the very edge, and then 4 centimeters away, draw an arc around like this. Okay, obviously this is not accurate. When you get a protractor, you want to draw it as accurately as possible. Try not to go over it a bunch of times, because if the length slips slightly, you're going to end up with a messy construction, which is never good. But then what you want to do is then take your compass again and move it now so that instead of being 4 centimeters, you stretch it along and put it on the 8 centimeter mark, so that your pencil comes down to here. This is your 8 centimeter mark, and then you want to take your pin, again this part, place it on the edge of this line, and 8 centimeters away you can draw an arc, and this arc is going to look like this. Now again, this is not accurately drawn, but you will find that you'll have some crossover point, and that crossover point will be the point where you can draw your triangle to where it works. Okay, so this is going to be 4 centimeters and this is going to be 8 centimeters, and usually they'll tell you to leave your lines of construction there so they can show that you've done the right method to it. Okay, so this is how we're going to construct triangles. If we know the length of the triangle, we're going to use a compass. If instead of knowing the lengths we know the angles, we're instead going to use a protractor. So let's say we've been given the same setup. We have a length here that's 6 centimeters, and we know that one of the angles is going to be 30 centimeters, 30 degrees even, and the other one is going to be 50 degrees, meaning the one that we form has to add up to 180, so the other one has to be 100 degrees. Okay, so we know these three angles. Okay, so we know the three angles in this triangle are going to be 30 degrees, 50 degrees, and 100 degrees. Now I would usually take these two, and I would say line up your protractor. So your protractor is going to look like this, your semicircle protractor. It will usually have some sort of circle in the middle of it. That's where you want to put the very edge of your line, and then you want to read across until you read up to about here where it's going to say 30 degrees, and then you want to make a little dot just above that 30 degree angle. Okay, then you can remove your protractor and you can go to the other side. So knowing this, you can leave that there, and then you can line it up with the other side over here where you're going to have your thing lined up. I would go with 50 degrees in this case, and you're going to read across from this side, and then you're going to see that 50 degrees will be about there, and then you're going to make that little dot there as well, and then you remove your protractor again. Okay, so now we have two little dots. What we're going to do is we're going to draw a straight line through both of these dots until they cross at a point. Okay, so again, this isn't drawn accurately, but you want to get a ruler and you want to draw across up to here through that point, and then take a ruler from this point and draw up and across and up to that point. And this is now your constructed triangle. So you've basically designed it so this angle is 30, this angle is 50, and this angle is 100 degrees. So I recommend having a go at constructing any triangle. You can make up triangles as long as the angles add up to 180. You can use this protractor rule, and as long as two of your sides are shorter than your third side, then these will make triangles as well. So this is how we do constructions of perpendicular bisectors, angular bisectors, and triangles. Hopefully this all made sense with your imagination, and thank you for watching. Hello and welcome to this video. In this video we're going to go through some exam practice on looking at construction, so working with compasses and protractors and rulers and drawing and that kind of stuff. So in this first question we've been given a map. The map shows two towns, so we've got Burford and Hightown, and we've been given a scale for this map. Okay, so the scale is that every 1 centimeter on this map represents 10 kilometers in real life. Okay, so the warehouse will be less, so the company is going to build a warehouse, and this warehouse will be less than 30 kilometers from Burford and less than 50 kilometers from Hightown. So shade the region on the map where the company can build the warehouse. Okay, so this is going to be a compass-based question. So what you're going to want to do is you're going to want to find your ruler, and then 30 kilometers, since every 10 kilometers is represented by 1 centimeter, you want to open your compass, so you get the pin on your 0 and your pencil on the 3. This is your pencil. And then use this, placing this pin part on this section here in Burford, and then you want to draw a circle around the edge of this. So your circle is going to be approximately 3 centimeters, or yours is going to be exactly 3 centimeters. The one that I'm going to draw now is going to be approximate because I don't have a compass, but it would look something like this. Okay, approximately 3 centimeters. So yours, you'd be able to measure to every point and see that this is going to be a 3 centimeter radius. Okay, so that's your first step. Your second step is it also, so it's and, has to be less than 50 kilometers from Hightown. So you now want to remove your pencil from the 3 centimeters, find where your ruler goes up to 5 centimeters, and then put your pencil over there. And then you want to take this point again, place it on the center of Hightown, and then draw a 50 kilometer circle, or a 5 centimeter circle in our case, because we've rounded it down, and that should look something like this approximately. Okay, and so we're asked to shade the region that satisfies both it being less than 30 kilometers from Burford and less than 50 kilometers from Hightown. If it's less than 30 kilometers from Burford, it has to be in the circle of Burford, but it also has to be in the circle of Hightown. So it's going to be this region in the middle is the region that we want to shade, because this is where both of those things are satisfied. Okay, so a very similar type question. Here is a scale drawing of an office where every centimeter is actually representing 2 meters. A photocopier is going to be put in the office. A photocopier has to be closer to B than it is to A. Okay, so it has to be closer to B than it is to A. The photocopier has to be closer to B than it is to A, and the photocopier also has to be less than 8 centimeters from C. So show by shading the region where the photocopier can be put. Okay, so this is a little bit trickier because the first thing, this 8 meters from C, we can do pretty easily. If every centimeter is 2 meters, then we want to only 8 meters is going to be equal to 4 centimeters. So you get your ruler, you put your pin on the 0, and then you find where it is 4 centimeters, and that's where you line your pencil, and then you keep that length the same. Place your pin of your compass on your point C, and then draw a 4 centimeter circle, or this is going to be just a quadrant here because it doesn't have to go outside of this office. And then, so this one is quite easy, but then the photocopier has to be closer to B than to A. So what we need to find out is where is the halfway point between A and B. Now we could always just measure this with a ruler and show where it could be, but a more accurate way of doing this is by finding where is the perpendicular bisector of the line AB. Okay, and if you remember, what we did was the first thing we had to open our compass and place so that it would be able to draw a curve that was more than halfway across this line. Okay, so that's the first thing. Then we wanted to place the point of our compass on one edge of the line and then draw your arc. So your arc is going to look something like this on average. Then we want to remove our point from here, place your point on A, and then draw a similar arc, and it should look like this. And you can see that these 2 points are going to form a straight line. So if you form a line that goes through here, and I'm going to extend it all the way across, it means that everything on this side of the line is closer to B than it is to A. So we know that the photocopier has to be on below this line, but it also has to be less than 8 meters from C. So it has to fit into this section here, because it has to be within the circle, but also below the line that we've just drawn as the perpendicular bisector. Okay, so now Finally, we're going to look at some examples where they might ask you to form a angular bisector and then a perpendicular bisector, or not even a bisector in the second case, just a perpendicular sector, I guess. So use a ruler and compass to bisect the angle A. Okay, you must show all your construction lines. So this is an angular bisector. Okay, so an angular bisector. The first thing we had to do was to open our compass so that we could draw a curve on both of these lines. Okay, it doesn't matter the length of the compass, it just has to be reasonable so that we can draw a line on both of these things. You want to place the pin of your compass on A, and then in one sweep maybe draw an arc on this length, and at the same distance away an arc on that length. So this should match up to be part of a circle. Okay, so this is your first step. Now, without changing the length, so you have to be really careful not to change the length, take your point off of A and put it onto this point here, and then draw an arc using the same length. So it should look something like this. Then you want to take your point off of there and place it onto this point, and then draw another arc with the same length that should look something like this. And then this point here, if you match a line up with A, should be the perpendicular bisector or the angular bisector of this angle. Now this one's a bit skewed because I don't have a protractor. These are rough sketches of what you would want to do, but if you try and carry this out by yourself, you should see that it would be exactly half. Okay, and now this last part of this question is to use a ruler and a compass to construct the perpendicular from the point P to the line QR. So notice this is not a bisector because P is not in the middle of this by any means. It's definitely closer to R than it is to Q. So your method for this is going to be slightly different. So what you want to do is you want to place the pin of your compass on R here, and you want to measure your length so that your length goes up to here. So your pin of your compass is on point R and the pencil should touch point P, and then using that length you should be able to draw an arc that would go all the way around like this. Okay, then you want to remove your point from R, and the difference here is that we can now change the length of the compass. And so we're going to put the pin on point Q, put the pencil on point P again, and then draw another arc with that length going around and coming back. And then you should do the same thing, and then if you draw your line through this top part here all the way through to the bottom cross section here, this line here is your perpendicular line. And you can tell that because it looks roughly perpendicular and is the perpendicular from point P. Okay, so if we're not looking for an exact halfway point, we can just put it wherever we need it to be, as long as we have somewhere that matches on both sides. Okay, so this is constructions practice. Hopefully this helps, and thank you for watching.